My name is Jay Bunner. I'm the program manager of the Emerging Technology Program here at Full Sail University, and we focus on cloud information technology. I'm hosting the session tonight is titled Problem Solving for Full Stack Distributed Systems. So please put your hands together and help me welcome our panelists tonight. First of all, we have Peter Washburn on the end here. And
Hi.
And Peter is the development manager with Full Sail Online, so the platform that you guys go and turn all your assignments in and everything on. He's the responsible for making sure you guys get to turn everything in on time. So, and then we also have Stephen Rivas.
Hello.
And not only is Stephen a web design graduate from Full Sail, but he's also a senior full stack engineer with Netflix. And then I also want to welcome Thomas Meeks. And Thomas is the Chief Technology Officer with Code School, which is located here in Orlando. So I want to thank everybody for joining us tonight. So first of all, I guess let's start off and what would you guys kind of define as far as distributed systems? What's I know there's a lot of talk about DevOps, and that's kind of a buzzword that goes around a lot these days. But in your realm and in your world of everyday use, what types of things do you see? Do you want to?
Are we like open forum, or do we have an order? They said we had to sit in order, so I don't know if we also answer in order.
Yeah, go ahead, Stephen.
Well, I'm relatively new to distributed systems. I've been doing it at Netflix a little bit, and at a startup before that. So. Really, to me, it sounds like self-defining. So it's like, a distributed system is a system that is distributed. But I've been trying to kind of break that down and see if I could come up with a kind of a succinct way to describe it. So if you imagined that we have a consumer down here who's going to use a product, and say that he's going to eat any Skittles that we give him, but we've decided for whatever reason that we only want to give him yellow Skittles. We might have someone who's in charge of opening the bag, someone who's in charge of sorting out most of them, and someone who's going to package them up and give it to him. So it's distributed in that sense, in that we all have our own responsibilities, and he can only eat yellow Skittles if I sort them, but also I can only sort them if he opens the bag and if he delivers it. So that's kind of the best simple analogy that I could come up with, is just something where a lot of things work together to achieve a common goal.
Great. I think that's a great analogy. So I never thought of it that way before. So, yeah. But what do you guys think? What do you think, Thomas?
Yeah, I definitely agree with that. It's all about having multiple, sometimes large, sometimes small systems talking to each other, usually over a network, sometimes not, that are just trying to make something that seems simple work in the most complex way possible. Usually, when you're talking about distributed systems. So, yeah.
All right, Peter, what about reliability? How does that play into all this?
Well, with distributed systems, when you have pieces that are spread out, and you have systems that are managing certain pieces of work, you basically now have an ability to not only test those pieces in isolation and ensure that that piece is doing exactly what it's supposed to do, but you also now can scale. You can ensure that, hey, if with the Skittle analogy, if you have 5 workers that are in charge of opening the bag, you can accommodate that load that that task might demand. So I think in terms of reliability, you have I guess it's a trade-off, right? So you have multiple points of failure that with multiple systems, multiple parts of that could fail, but at the same time, you don't run the risk of having a single monolithic system that if it fails, everything is gone. Right. So you have some kind of I guess firewalls, where, hey, this is broken, but these other pieces are still working and serving out your application. So
great. As far as we kind of touched a little bit with your Skittles analogy about differentiation of services and things like that. I'd be kind of interested to hear what your experiences are in terms of, from both small types of systems all the way up to obviously Netflix. I read a statistic the other day that said I think that supposedly it's up to about 35% of all internet traffic now terminates at Netflix. So it's a pretty big number when you think about it. So obviously you guys work on a much different scale. But even on a smaller scale, how do those differentiated types of services play into how all of this works?
I guess for FSO, currently it's a monolithic app. We don't have a lot of services right now. We're working towards that. I guess most of you guys have used the platform. So when we launched 3, one of the problems that we experienced were we can test our best estimate of like people's usage of the system, but until it's actually live and people are actually doing schoolwork and their teachers are interacting, we don't really have a good idea of like exactly like what the load at points of our system is going to be. So the challenge is that trying to separate those pieces into more manageable segments where we can actually like do metrics and prevent people from experiencing some of the problems where like you go out at midnight and because there's extra 2,000 students submitting, you're not running the risk of your assignment not going through or receiving errors and those types of those issues. So.
Yeah, so over at Code School, and normally I wouldn't recommend this if you were creating an application from the very beginning to start distributed, but we kind of had to for security reasons because we let you type in code and we run that on our servers. And obviously we can't run that code on the same server where we're, say, processing credit cards. Code School is broken into 5 different clusters. One of them is our executors, or actually 2 of the clusters are executor servers, and they're stateless. And it's kind of the big part of our distributed system is that if we get a lot more traffic, we can spin up more of those stateless execution servers whenever we need to. So it helps a lot with handling more traffic and with reliability, especially if someone sits down and decides to submit a bunch of infinite loops or anything like that. And sitting in between our main app, where we're processing all of credit cards and everything like that, we call it our .com or internal side, is the courses. So when we first started Code School, every course was actually its own app. So it was an extremely distributed system with all those courses talking to Code School talking to all those courses, and all of those talking to different executors depending on exactly what piece of code you need to do. So it was a really, really good way to scale out the product quickly, since we didn't necessarily have to worry about if we want to do something different on our next course, we didn't have to worry about breaking the old course that we just released a month ago. So.
Yeah, and we have kind of like distributed systems within our overall distributed system at Netflix. So I work on the content platform engineering team, and we're in charge of all of the content that gets ingested into the catalog, and we send that down the line that later gets like processed again, and then they add some metadata to it, and then it goes to, I think, the API team, and then they serve it out to the UI. So that's itself is a distributed system, but we also have like even on just CPE, we have systems that are very kind of intertwined. And it's it's kind of tricky making sure that you break them down into logical, like modular pieces that make sense, and then also providing some sort of like safeties and failover switches. So if you guys are like ever on Netflix and you're scrolling through and like, hey, there's a movie title and like there's no image and it's just gray. That's kind of our fault. And it does happen. So, if we decided to, instead of sending a gray image, if we didn't have the correct image for that particular user or test, then maybe that movie wouldn't show up and you guys wouldn't be able to enjoy that movie. So you kind of have to make sure that while you're thinking about breaking things down into pieces, like what other parts of the system will be affected later when something does fail. And it's when, not if.
Right. Because failures happen all the time, and it's and part of the design is to make sure that you have addressed that and know how to basically recover from it's basic fault tolerance, right? So we know things are going to fail, systems are going to fail, networks are going to fail. It's just a fact of life.
Yeah.
So let's talk a little bit about full stack developers then. So where do what and again some of the definitions kind of are all over the place, but in terms of full stack developers, what do you guys see in terms of some of the types of understanding all the different parts of the project and understanding what different stakeholders want and everything. What's been your experiences with being in kind of that role?
Well, it's been kind of interesting. Code School as a product grew out of a consultancy called Envy Labs. So when a client would come to you, you would definitely have to do full stack development end to end, start to finish, because sometimes it'd just be one developer on certain projects. And in that case, you're a generalist if you're a full stack developer. You need to know how to get it onto the web hosted somehow. Maybe that doesn't mean you know how to use Linux. Maybe that means you are really good with Heroku, right? And that's fine for smaller projects, or even bigger ones. There are some pretty big things on Heroku. So it's also about understanding the front end. Maybe you're not a designer, but you need to know enough CSS to be able to put that together. So most important part, though, is kind of that middle piece, right? Because usually where a full stack developer lives and breathes is either early application development or inside of the framework itself, right? So whether that's Rails or CakePHP or anything that you're using, it's really important to live and breathe that and know it. And even more important than all of those things is, like you said, client requirements. Getting information from stakeholders. That's a really easy thing, and it's really difficult to teach in school. But it's something that's super important to be able to walk into a meeting, talk with people who are not programmers, figure out what it is they're actually trying to solve, and get them to boil it down to what they want rather than how to do it, which is a super important skill to try and grab, and it's something that a full stack developer has to be able to do. Otherwise, they don't necessarily know what to do, because full stack kind of implies that you don't really have a project manager there helping you with the business side of things, right?
Yeah, I think it pretty much boils down to full stack means everything. And I kind of like to think of it, as long as if you want to be a full stack engineer, you need to be open-minded and willing to learn. I used to absolutely hate UI design, even just the JavaScript part of it. I was just like, browsers? No, I don't. Go away. And so I kind of boxed myself into what a little bit more towards the back end. And coming over into full stack roles, it's really just about, hey, I can't just sit here and oh, this thing isn't working, and that's outside of my job role. I don't know what to do. There is a lot of value in being a specialist as well. It's not the world has roles for both, but if you're doing full stack, you kind of need to be able to say okay, I need to context switch a lot, and I need to be willing to learn and change. And I may not master something. I may not be the guy who writes the big O of n log n algorithm, but I can talk with that guy about it, and let him know what I need, and I can also go into the meetings and discuss with the clients why we're doing this. So.
But I'm glad that you brought that up. That so understanding a lot about what other teams do is very important. Then. So yeah, and even if you aren't the master of that, you at least can communicate that with other teams.
Yeah,
is kind of what. Yeah. So what do you think, Peter?
That's been my experience too. Throughout the years, I started off as basically just a Java / C++ developer. You kind of get into a role where you're at a job now and they have web apps, and it's just another language. It's just another tool that you use to do your job. So over the time, you kind of pick it up and you become more experienced, more comfortable with it. Ultimately, if you have a web app, you're probably talking to some database or cache server. There's some other pieces that have persistence that you're actually pulling data from and displaying it to the user. So, you have to be able to interact with those things and be able to, do your job with these different technologies that aren't part of your everyday responsibility. So, the jack of all trades thing, I guess, kind of is really what is a full stack developer. You're probably not going to be a specialist in any one part of that stack, but here at Full Sail, we try to hire. We've tried to hire full stack developers, but what generally happens is there's some niche that person's filling, because you're probably going to work at a place that has DBAs or server teams, and they're going to be the ones that are really focused on getting those systems working the way they are. You can't. I personally, I feel it's unrealistic, I guess, undertaking to become a master in all those layers. It's just, there's so much in, if you're doing development, there's so many frameworks, there's new languages, there's new ways of doing things that you can spend an entire career just, keeping up with that to, throw in these other things that maybe aren't your day to day. It's just, I've always thought it was unrealistic. That's.
Well, it's a high expectation, right? So
yeah.
So if you had to, let me ask you guys this then: if you can't master all of it, though, what are some of the types of things that you should at least be aware of? I mean, are we talking, frameworks, programming, networking, the server side, Linux, that type of thing? I mean, what are some of the essential skills that even if you don't have a complete mastery of that you need to be aware of?
Source control.
Source control.
Number one.
Yeah.
Figure out how you're going to work with a team on maintaining that source, because that's just start there for sure.
I would toss out servers, understanding Windows, Linux, anything, something, because when you start getting a little bit of traffic, anything past kind of that trivial point, understanding the very, very basics of just how routing works, how networking works, how a Linux server doles out ports and things like that, just in the back of your mind, will save you so much pain, and will save your ops people so much pain if you have ops people. And if you don't, you'll at least know where to go, right? Because there's nothing worse than being in that situation where something goes down and you're just lost and you're just no idea where to go at all. That's a very bad place to be in. So I would kind of tend to put that on the higher end, because, it's a lot harder to call in a consultant at that point. They need to learn your system. They can't fix it in an hour. So
I would say probably being able to read documentation and knowing where to go to find help. A lot of open source projects have IRC channels. A lot of them have Google groups. Being able to go on there and talk to people that are using the same technology you are to try to figure out like what's the best way to solve my problem, or get help on understanding, because if you're using a framework like Rails, for example, that framework is massive, right? So if you're not following the golden path and you've strayed off because your app requires you to do that, and the community's not there to help you, either A, you need to be able to read the documentation to figure out the best way to like solve the problem for your application, or you need to be able to go on to these forums and find people that actually are very knowledgeable in that framework to help you through your situation. So.
And I'm kind of glad that you brought up the frameworks, because that was one of my next topics, was about the frameworks and languages side of things. So in terms of, and let me just kind of take a quick poll or have you guys talk about, in today's environments, I mean, obviously, frameworks, both front end and also back end types of frameworks, have really become very popular. I mean, what are some of the things that you're seeing? What are some of the trends and the up and comers, maybe, if you will? I mean, what's out there today, and what do you think is what is the landscape going to be like in another 2 years? I mean, if you had a crystal ball. So.
Yeah, let me look into the crystal ball. Actually, Thomas, do you have one?
No, I'd make some guesses of what I'd like to see happen, but right. So I've been really surprised at the rise of the front-end JavaScript framework. I started my career doing desktop development, and I'm not really sure why anybody wants to do desktop development. Web development's kind of nice sometimes, but then you look at Netflix and all of the amazing things that they do. I don't know if you guys are using a framework, but then you kind of get reminded why HTML can suck. So, Angular is a big thing. We see that. We use it at Code School. All of our newer courses are served up with Angular. Well, on the front end are Angular, and it's our most popular free course by a pretty wide margin, like a very surprising margin. And Ember's not too far behind. They're both really good frameworks, and I've heard a lot of good things around the office about React too. On the server side of things, it's really hard to judge. Rails has kind of slid into its maintenance phase almost, it feels like. It doesn't generate as much community buzz. We still use it. And on the JavaScript side of things, nobody's figured out which one's their favorite yet. There's a few that are pretty popular, but a new one's coming out every other week, so there's no idea where it's going to be in a couple of years.
Yeah, so I personally don't think that frameworks and/or languages are important at all. I think that it really depends on what you're building and who you're building it with. As far as like some of the new JavaScript frameworks that, like you said, they are coming out all the time. Some of them aren't even frameworks, but people are just like, oh, it ends in JS, so we'll call it a framework. I just recently started playing around with Flux and React, which I don't consider a framework. Just more of an architecture and a view renderer. But it was really nice to kind of be in a system that was, where some of the answers were already defined again, because we had previously used Backbone. And it's very unopinionated. It just does the bare bones, and it's great. But when you have 15 people working across several projects, if they can all do it different ways, they will. And then you have to go maintain that. Whereas if you pick something, like even Ruby on Rails, I know they're kind of just like, hey, you drink the Kool-Aid and you do it this way, or you can't play with our toys. And that's actually good in some areas. I know I'm typically like a Rails hater. It's just we use Groovy on Grails right now for our backend, or our middle tier, I should say. That serves our web applications, and I think Pivotal Labs is the company that was funding it. They're going to stop that after 3.0. So, as you're looking into frameworks and languages, you have to know that, and this is why I don't think they're very important. They're going to change over the next 2 years. They're going to disappear. They're going to fade out. You're going to have to pick something new. So it's really about what you're trying to do and what you like, what tools you like to build it, and if those tools can even do that.
Yep.
I agree with Steven. Currently, FSO is a Ruby on Rails application, and you get to the point where we're trying to scale, we're trying to do all these cool things. There's only like 3 actual back-end developers, so we're kind of spread thin. But we start seeing as like, well, the framework was great to get us like off of the previous version, and now that we have these deadlines, these feature sets, it just doesn't really fit what we're trying to do. So we've actually started moving away from Rails, the framework. Our code's still in Ruby. It's now services, and we looked at Angular and Ember, but it's another framework. It's another tool that's telling you basically this is how you need to build your app, or you're not going to be successful. And we're actually doing our front end in React because it's just a library. It's not a whole framework that someone has to learn. It's just a library and some tools. I guess the catch-22 though is what generally happens at places I've worked at is you don't use a framework, and what happens is you kind of start building these tool sets because as new people come on, you want them getting up to speed very quickly and being productive, and you kind of internally build your own framework, and I guess the only positive of that is it's your framework, So, if Ruby on Rails, or if Rails dies, you're not out there holding the bag by yourself trying to like keep that framework going because you're depending on it internally for your application. So, it's hard to say. Like, obviously the JavaScript world's kind of accelerating very fast lately with a bunch of different frameworks every like 2 weeks or something. Back-end technologies have, I think, kind of, plateaued. You have a set of frameworks that you're using like Spring or, Rails or Django or something generally, where people just write, straight up, little worker processes and they're sending HTTP requests to them, so.
Yeah, and I noticed, it seems like, and I think one of you brought up, a lot of .js. I mean, Node seems to have a lot of popularity, a lot of buzz around it in the last couple of years or so. And it seemed kind of like the go-to, that everybody was going to. But what's your thoughts on that? Do you think Node's going to continue to move at that same pace, or do you, as far as a backend framework?
It's kind of like the short answer is yes, but it's also Node, and there's that whole Node and IOJS thing, and like where's the community going, and that we could argue about for hours, I'm sure. But I do think that the Node community, or at least the community around those 2 projects, will continue to do very well. They are growing very rapidly. People used to say there's an app for that. You can now say there's a module for that. You get on NPM. That doesn't always mean that they're great modules, but there are modules out there for almost anything. But they are accelerating very well, and I really like the thought pattern that they've adopted and pushed. It's nothing new. They've kind of like borrowed it from the Unix days of just like small things that do one thing and do it well, and then you kind of stream or pipe that to the next one. And I'm seeing a lot of that, kind of like really take hold in Node, and I think that it's going to do really well. We're considering it for actually some of our UI teams are already implementing things in Node. If you get a chance to check out like our tech blog, they have a talk on scaling A/B tests. that they did with Node. We're probably going to start using it for some of our tools to kind of like, test the waters and see if we want to move there or stick with Grails or find something else.
Mm-hmm. Yeah, Node's definitely going to continue doing well. One of the nice things about Code School is that in order to teach it, you have to use it. So, we ran JavaScript code inside of Node, and we managed to shove that into the browser now, so we don't have to run Node servers for at least the code execution part. We do use Node for some of our new executor, actually, because it's a great way to build small apps. It's a great way to do microservices if you need to do that. It's a great way to be incredibly efficient on a server. A Node app is probably 2 or 3 orders of magnitude more efficient than Rails when you're first getting started in terms of efficiency on the server. So yeah, the community has got a lot of innovation there, and it's really nice to see that happen. I think sometimes you have some complaints about Node kind of reinventing the wheel over and over again, but that's how things get better, is reinventing that wheel over and over again. And that's kind of also the beauty of the modules. The community is really open about doing that over and over again, and eventually the code's going to get amazing, and there's not going to be that many bad modules left anymore. So.
Yeah, you mentioned about microservices and that type of thing, and I'm thinking some of the audience may not understand some of the architecture side of things. Could you maybe kind of explain a little bit more about kind of the architecture and the strategy behind those types of things?
Sure.
How do you? I know we talked a little bit about differentiation before, but how will that actually work in the real world?
Sure. So the idea of microservices is take what you would normally consider a service. Code School handles credit cards, logins, all kinds of stuff. A microservice would do one thing, kind of like in the Node mindset, and do it well. So it might only do logins, or it might only do credit cards, and only a portion of handling credit cards. I think one of the more interesting microservices that's often our parent company, Prolosite, is one that just generates PDFs. That's all it does. And it's super generic, and it's almost like a command line utility. So that's kind of where you get to the point. You don't see it all that often in smaller apps. You kind of start to see it in larger apps where nothing is simple anymore because of the scale that they're operating at, or because of regulations or anything like that. It's a nice way to take a tiny piece of functionality, break it over into a separate service so that it can scale and you can do different things with it and whatever you need to do, or especially if another team needs to work on it. So.
Yeah, totally. I mean, we have like logging. Logging is really hard to do. Where do you put the logs? Where do the logs go? How do you look at them later? I think that's a great example of a microservice. It's something that you're like, hey, we just take our logs and we shoot them off over here. And that's just an ingester, and all it does is just like, okay, cool, thanks for all that info, and then later we'll build another service around that to say, okay, now I want to go break this down, or like, provide some dashboard visibility into the logs. But that's one thing that can be like in every application across any stack, but you can just kind of take it out and put it over here and say, okay, everybody now can use that logging. So now all of the rest of the stuff that you build already has logging, as long as you just use that one API. So if you have 4 or 5 different things like credit cards, logins, and all of that, and say that you wanted to add something that would allow users to put a profile picture on Code School, which I'm pretty sure you can do. But if we were going to add that, then we don't have to rebuild logging for the profile picture, because that one's already tucked away.
Yeah, in a more general way, you could kind of think of it like a module that communicates over HTTP usually, that kind of thing. It's the smallest amount of code that you can get to do that one tiny thing. So there's a lot of noise around that in the community right now, and it's because it's the kind of thing that you have to do once you get really, really big. So
it's really hard to do. Just because you're like, oh, hooray, we didn't build a monolith, that doesn't mean that you have a great application. You can have, one really bad monolith or 30 really bad microservices, and it's still going to, be kind of. So it's not an easy task to break them down.
Yeah, it kind of brings up a good point, is every time you distribute something, every time you have something communicate over the network, there's things you have to keep in mind, like the network is not infallible. Packets do get lost. TCP doesn't always handle that correctly, right? So when you're making a call, there's a kind of like an old way of doing remote calls in C++ and Java, like remote procedure call, where someone kind of came up with the idea, like, it'd be so great if I could call a method on an object, and I don't know if it's remote or local, it doesn't matter. And that's the worst thing ever. There's nothing worse than that, because you call .log and suddenly you get an HTTP error in the middle of your application where you never expected that to happen. So, doing a distributed system is very useful, and sometimes you need to do it, but don't consider it the easy way. It's much, much, much more difficult than building a monolithic app. And oftentimes it's better to prototype as a monolithic app and then go distributed and take all of your, ideally you'd be building, good APIs inside of your application, and then you can tear those out into microservices as you grow and scale and as it makes sense.
Great. Well, let's talk a little bit about the deployment aspect as well, because we've kind of touched on a little bit. I know you mentioned about Heroku and things like that before. What's your take on containerization and Docker and some of the buzz around that? Is that something that is there a place as an application? Is it something that we're going to see mainstream, or is it something more just like a prototyping type of tool?
For FSO, we're using a combination of Vagrant and Chef, and we're using automation through like a Capistrano, which is basically just a Ruby application that provides you a DSL for doing deployments. I just don't think that stuff's going to go away. I mean, the DevOps stuff is becoming a big part of the application development process, and it just makes it easier, especially when you have if you break out from a monolithic app and you have now SQL migrations that you need to go update your database, or you have all these different servers that you need to deploy code to. You're not going to go there and each server deploy some code. You're going to want to run something and have it automate all that. So there's not human fault in that process. You're just not going to do it. So I don't think that stuff's going to go away. And there's numerous tools. I'm not really familiar with Docker. We don't use that here, so I can't really speak to that.
So Docker is probably going to be, it's already pretty big, and it's going to be much, much, much bigger as time goes on the server side of things, because it has the potential to make a lot of things that are difficult on the server much easier. Sitting down and setting up a PostgreSQL server in the right way, outside of the defaults, is not necessarily an easy thing to do. And if somebody sits down and creates a Docker for you that you can just fire up on your machine, that makes it a lot easier for someone who's new to that kind of thing. It's also really amazing for security. All of our new code execution is based around Docker, because you can let people do more without getting into the server itself. So it's kind of interesting on that too. So if you know that one day you're going to scale out, maybe you have a lot of VC funding in a startup or something like that, and you want to prepare for it, you can prepare for it while still being cheap by loading up a bunch of Dockers on one server, right? And then once it's time to scale out and get bigger, you can take those Dockers away from one server and put them on multiple, and put them on bigger servers and things like that. So it's a very, very, very big deal. And I think around that, in order to make Docker sane, you have to use some kind of automation, whether it's Chef. We use Salt over at Code School, Puppet. There's a bunch of them out there, and one of them are going to be very important in the tool set of anyone using a lot of Docker stuff. So.
Yeah, I have not used Docker myself yet either. I heard that CoreOS, it was also building their own spin on that. There was apparently like a big security issue in Docker, and they decided to just make their own and fix it. Because the CoreOS guys are like genius, But I think that containerization is going to continue to get more popular, we have a platform team that's kind of explore. We explore new technology all the time at Netflix, and so I think they're kind of exploring maybe using some of that there. Right now, we use a tool that we open source called Asgard that sits on top of the Amazon infrastructure, and it's just a red-black push, which basically once you set up your load balancer, which comes like all of your web traffic is going to come there. then you build up like a base AMI or like a little virtual server or whatnot that has all of your code, and once it starts up, it's a full functioning virtual server. So we'll put a version of an application, and maybe we'll have 20 or 30 servers for that application in this cluster. The ELB will route traffic there, and then as soon as we get the B version ready to go, we'll stand up maybe 20 or 30 of those, make sure they're all passing health checks, everything's running smoothly, run some QA and some automation tests on them, and as soon as we're ready, we just route traffic from A to B. We'll still have A around. It will probably deactivate it, or in case we need to switch back really quickly, so that we don't have to roll back or anything like that. It's just like a whoop, going back to the old version. But that's how we've been, and we did that actually at the company that I was at before Netflix as well. So those guys actually came from Netflix and then kind of re-implemented the Asgard infrastructure there. So if you get a chance, it's a pretty handy tool if you work with Amazon. It's a little complicated to set up for just a for fun project, which is why things like Docker will and other container stuff will become more and more popular because they're easier to do for smaller applications. So you probably don't want to sit around and spend a week getting all of your infrastructure set up, so you can just push one server.
Right. So could you maybe for the audience that maybe doesn't understand completely how some of the containerization works, could you maybe give us an example of the process or what the advantages are, how that takes place, how that works?
With containerization?
Yeah.
Okay. So I haven't used that. We're doing. We use virtual machines. I think pretty much everyone is using virtual machines now. I don't know anyone who actually stands up their own physical servers anymore, unless they have really good reasons to, or just a lot of money and they like painful projects. So we set up virtual servers on the Amazon infrastructure. And I think that that's the EC2 kind of domain. And any server that we spin up, we give it an AMI file, and it's got all of our code and whatever else we need for that project, for the base, deployed to the cloud with all of the Netflix options or whatnot. And we just kind of stand up. It depends on the application too. So. What we like about Asgard, or what I like about Asgard, I should say, because I've seen it work really well, is the fact that I can have 5 servers running, but I could also say that the maximum amount of servers that should be online is 15, so that Asgard and Amazon can automatically handle that. If they notice that the servers are starting to slow down, or maybe increased load, they can slowly start spinning up within a cluster, before we're even necessarily aware. It's not something, it should be automated, like you guys have said. We don't want somebody there monitoring all the time, oh, I should go turn on another virtual server. It's oh, hey, just when you get to this point, start standing more up, and then if it becomes a problem, we'll know. So yeah, I haven't really used containerization, but for what we do, we just do virtual servers on Amazon.
The real big difference between containers and virtual servers on Amazon is that when you fire up 5 virtual servers on Amazon, it's 5 different kernels, and they all have to go through the boot process, and they are all running things like syslog and all the different services that are required to make Linux work. When you fire up Docker, you can actually strip Docker down to the point where it's running almost nothing. And the boot up time for a Docker instance is milliseconds. You can actually run Docker real time based on commands and things that happen, depending on what exactly you're doing, in order to execute client code, in our case. So that's kind of the huge difference, is that if I need a service right now, this very second, in the middle of a request, that's kind of feasible with Docker. It's not at all feasible with Amazon, where no matter how quick Amazon is, it still takes a few minutes to provision the servers and boot them up, and then you need to run your Chef or Puppet scripts if your AMI is just a little bit out of date to get the freshest code that was committed 5 minutes ago, that kind of deal. So that's the real big difference there. They have very different use cases. You don't fire up more Dockers in order to scale, because you're not getting more hardware out of that. You just make one server run slower. It's maybe the more common use case would be a much smaller Asgard, where you want to fire up an entire cluster on just one machine, fire up an entire second cluster on the same machine, and then switch from one to the other without firing up a bunch of Amazon instances. Maybe you can't afford it, or you want to do it for every single deploy. I think that's probably going to be a pretty big thing in the Docker realm before too much longer, where people are firing up brand new Dockers and switching over to them on every deploy, which would mean, dozens of times a day, if not more.
That's an interesting use case too, because when you think about it, and with containers, like you said, they're actually running on the same kernel, so it's just kind of segmented off for security purposes and such. So now do you think in your particular case, in your experience with it, as far as security, how does that impact? I mean, does it improve security? Is it a best practice to do? Is that something that you think we'll see more of because of that?
I think we'll see more of it, but to kind of put it in the right perspective, Docker helps. It doesn't guarantee, right? If somebody can run a root command on a instance, on one of your Docker instances, then it's not necessarily easy for them to break into the owning server, the parent server, but it's possible because they're sharing a kernel, because they can make system calls. So it's something you kind of have to look out for. It does make it much more difficult because you can let them, say, run one command and then tear that Docker down and throw it away, which is nice so that people can't, say, modify the file system. But yeah, I think it'll probably become a best practice, but it's never going to be a guarantee. As long as you're sharing the same kernel, you still have that attack surface, which is that shared kernel. So.
Great. Well, let's talk a little bit about as far as career pathways and that type of thing. So, and I know the three of you have very diverse experiences in your careers and such. If you have to give advice to students today, if you were in their shoes, what are some of the things that you in your career and your what you've done that you found advantageous, and what would you change? What are some of the things that you might do differently, or if you had a chance to do it now? I'll start with.
I started when I was in college. I did a lot of C++ and Java. I don't do any of that really today. I still do some Java stuff. Some of FSO runs on Java. But as time's gone, as time went on, like you get into these different positions and different jobs, and you're asked to do stuff, or there's a need. There's like someone's like, oh, this one-off project, and I always try to take advantage of those one-off projects. Like there was a .NET thing. I don't know, a couple years ago here that we just needed this. I think it was Microsoft 360 integration. No one wanted to do it. I stepped up to do it just because it's more experience. It was something else to learn. So for me, it's always been like trying to learn as much as you possibly can, and everything I've learned has been centered around development. I don't really venture off into the server world or DBA stuff. It's really kind of like, hey, I like developing, and I'm going to try to learn as much as I possibly can without going crazy. So that's probably the best advice I can give is just trying to keep learning, because as soon as you stop learning, you just get past, and it's hard to get back into it and caught up. So.
You totally stole my answer too. Yeah, I can echo that sentiment. Being able to learn and being willing to learn were crucial in where how I got where I am. I kind of realized a while ago, there's always somebody out there, there's always everybody out there who knows something better than I do. And I decided, I'm going to be really open-minded and willing and actually go out and seek that from that person. Like, what you're doing is really interesting, and I want to be a generalist. Sure, I can't master everything. I don't know if my brain actually works that way. But I do want to know how you do that and why you do that, and make sure that I kind of at least conceptually understand it, so that later, in some other conversation, it may just pop up like, oh, that's right, I was talking to so-and-so about that. That makes sense because they were doing this, and now that, just kind of being able to seek that information out and learn from anyone, even if you maybe don't think that they're your senior, or they may, a lot of times juniors will come in and they'll, really challenge you because they know stuff, or they don't know stuff, and it'll kind of make you go, oh, I need to relearn how this is working, because yep, they're bringing the new information up, and that's probably the most crucial thing.
Yeah, I could echo definitely, for sure, or I will. I mean, for sure, learning is the most important thing, being willing to learn. But there's a few other things you could do too, when a project comes across your plate, take it. When you're at work and something needs to get done that's a little bit outside of your, bubble, your area of responsibility, do it, right? That as far as career development, there's very few things that matter more than caring about your craft, about the people you work next, about the company that you work for. Just putting in that I'm here and I care, and I'm going to make sure that everybody's life is easier because I do great work, and I want to make sure that everybody else around me, that I make them better, right? And that shouldn't come from a point of hubris, because then you're going to crash and burn terribly one day. It needs to come from a point of helping everybody else around you learn, and seeking out opportunities to do that as well. As a corollary to that, get involved in your community somehow. It's super, super, super important early on. Whichever language you're interested in, go to the user groups for it, speak at them. It can be a little bit intimidating to give a talk, but it's actually really, really easy to give a talk at a user group, because usually they're in dire need for someone to give a talk. So offer, and they'll work you into a schedule, and that's enormously great practice and it doesn't even have to be something that you know already. It could be something that you want to learn, and now you have the drive to, because you've made a commitment to talk on a particular day. So
it's also really important to remember that it's not what you know, it's who you know, and that's a lot of why I came to Full Sail originally. They can't teach you everything here, not to burst your bubble. They have 21 months, and it's like, teach me the internet, go. It just isn't going to happen. It evolves way too quickly for them to be able to do that. So when I went through the program, I was learning ActionScript and Cold Fusion. Flash is dead. Why would you ever teach Flash? But a lot of what I learned there, will apply later, and it's still relevant. But it's who I met here and who pushed me. Kind of like a short story. Jason Madsen pushed me to submit my final project for the Node Summit 1 year as one of the new Node breakout apps of the year or something like that. And it got accepted, and we got to go out there and do that. And then I ended up connecting with CJ, who said, oh, hey, by the way, years later, we should meet up at another meetup or something when you're out here. And then I ended up working with her at Live, and she went off to NPM. And then I met somebody through CJ at Live who gave me a referral over to Netflix. And it just kind of you can connect dots in your career as well. So be open to recognizing there are people around you, people that you may be working with in class right now, people who you may come back in a couple years and speak on a panel like this and meet somebody, and then you never know. So.
Great. Well, is there anything else that you guys would like to add? Anything that we've missed that you think would be
Well, I
important?
think I'd like to mirror your comment that I'm where I'm at largely because of the people I knew. And, it's going out and meeting people and getting involved that helps. When you're at home and you're thinking, I kind of want to go and to something like this, like Full Sail Live or User Group or anything, and then you start to get kind of lazy, then that's the time to go and arrive early. So, yeah, it's super important. You can be the best programmer in the world, but if nobody knows it, you're not going to get where you want to be in your career.
And programming by yourself sucks.
It really does. Yeah.
It's never really about what you made. It's about hey, I made this thing and it works with that thing that you did and we built this. That's the best part of engineering, at least in my mind. And that's where you can really go really far. You can, what is the saying? It's something like you move quicker alone, but you move further together or something like that. You can build some really cool shit if you get a good team around you and learn from them and get stuff done.
Great. Well, I'm sure you guys probably have tons of questions out there. So for our panelists, so what I'm going to do is go ahead and open it up to questions from the audience and online as well. If you're joining us from online, and please direct the questions to your online moderator, and they'll try to get the questions into us here. So with that, do we have any questions from the audience? And I think we have a microphone. Yes.
All right, this is a question from Donald on YouTube. He asks, how do you find open source projects to contribute to? As someone who has been developing for a year now, I still find it difficult to find beginner to amateur projects and products to contribute code to.
I actually wanted to mention this in one of the portfolio reviews earlier, because the recruiter said, like, find open source projects and you know, send pull requests and like help build things, you know. Contributing to an open source project absolutely is not exclusive to writing code for an open source project. Just going through pull requests or watching things that happen on a repository, maybe opening up issues as you're using something and reporting on, like logical reports on those issues, like, hey, this is happening and here's why. Or maybe just monitoring like the overall project itself and saying, oh, you guys changed this and that's going to break this over here and you didn't update your change log or something, like, if you even keep a change log, I think. That's pretty rare. But you know, things like that count as contributing too, and you still get the little green dot for doing something for the day on GitHub. It's like, hey, you did something. You're an open source contributor. So don't be intimidated that like, oh, I'm new and I can't find something to code. You don't have to code to contribute.
And I guess, yeah, along those lines, if you do want to code, I know that a lot of projects have, they try to get into the, the Google Summer of Coding, and they usually have a whole list of projects for students. Some are super advanced, some are, very, I think, simple, but, you can definitely apply to those, reach out to the contributors and say, hey, I'm interested in applying for this, and just, trying to get involved. So.
The first thing that comes to mind for me is documentation. You can pick something really big, Rails even, and just start writing documentation for it. Every open source project always needs more documentation. And in the process, you're going to learn more about the code because you need to understand the code to be able to document it. And the programmers, no matter how famous and huge they are in the community, are going to be super appreciative of that. I think it was last year, it was either last year or the year before, Greg, the CEO of Code School, actually handed out a Ruby Hero Award to somebody right after the keynote at RailsConf. And their major contribution was writing documentation for Rails, and that's what they had been doing for a year. So people do recognize that sort of thing. Outside of that, it's anything that you use that when you find bugs, open up an issue, and after you open up the issue, maybe see if you can fix it, and then submit a pull request. And every once in a while, you're going to come across a project where the maintainer's kind of a jerk or something like that, and no big deal, just move on to the next project, right? There's so much stuff out there to do, and by and large, you'll find that if you're willing to help and you're open to working with them and working in the way that they're used to working, especially keeping up with coding standards and syntax rules and all that kind of deal, that they're by and large very willing to help you make those kind of changes. So, but yeah, start small, get to know the community, and move from there.
You can also write unit tests or any tests at all. There's like 130 some odd thousand modules on NPM, and like 6 of them have tests. And that will, by writing tests, you can also, you'll be learning about the module, but you also probably uncover that the code that was written is not written in a testable fashion. So maybe you can do small refactors, and they'll really start to appreciate that. I mean, even if you get one test in, now you have the framework. So anything from here forward, you can say, okay, I'm going to write this new feature, and the tests are already done. I just have to write, I don't have to do anything else and implement Mocha or Chai or whatever else. Or Cucumber, I think, is like something that someone was bringing up the other day. It's like there's a ton of test frameworks, but they're really annoying, and no one likes writing tests or implementing them. So if you do that, that's probably a good place to start as well.
Yep. Good. Excellent advice. I think we've got a question up here.
Nope.
Oh. Hey guys, my name is Jorge. I have a question for you. What is your opinion about projects like OpenName that are being built with the Bitcoin blockchain? That is a very big distributed system, and how you see it in the future working, like for replacing all our identities in the internet and probably in real life as well. How do you see it from the architectural point of view and from the security point of view as a distributed system?
Well, I think the security of Bitcoin is kind of interesting because it is secure unless if somebody has 51% of the total computing power behind it, which, if maybe 5 people got together, they would. So I think that by and large, you'll find that with those kinds of big distributed systems, Tor is another really great example where for a long time you could get on Tor and you could hide your traffic from the NSA, and then the NSA started firing up a bunch of Tor exit nodes, and that's not true anymore. So I think when it comes to, it kind of depends on the kind of security you're looking for, and I don't think that the internet, as great and wonderful as it is quite yet anywhere close to being immune from the big players making a choice to spend enough money to get around your security. So, but at the same time, I don't think that is ever going to stop. I think it's a very healthy conflict. A lot of people learn a lot along the way, and if they don't figure it out with Bitcoin's blockchain, they'll figure it out one day with another one. I think the internet just needs to get maybe 1 or 2 orders of magnitude bigger.
I think we have another question up here.
First of all, thank you for spending your time with us. We really appreciate it. And just to not spend time, I will go to the question. I would like to ask, what are the minimum components that a distributed system usually is composed of? And how does each of your companies test these individual systems running parallel at the same time? How does that local environment look like?
I think the first part of the question would be pretty tricky to answer. Like the minimum components in the system would entirely depend on what the system needs to be. So for the same reason that I don't get too picky about languages or frameworks anymore is because I don't know what I'm building. So once I know what I'm building, then I could maybe break down, okay, this is the minimum part of the system, and then here's the tools that we're going to use to build it. So that would be kind of tricky. But as far as testing things across distributed systems, I think that they make it easier to test for because, for example, we have a UI rolling out that wanted like lower res images. So while you're scrolling, like you're at least seeing something, right? So all the way across in our building, we built this system that will process all of the images that come through and create these like really low res ones, which actually ended up looking pretty nice on the iPad anyways. So we don't have to test that the iPad is showing images necessarily. We just have to test that this one is making the images, right? And then we can test that, like, oh, yep, this one's making the images. And then later we can test, is the iPad calling for the images correctly as it's scrolling? So in that sense, once you break things down and if you do it right, it kind of separates all of the concerns as far as like, oh, this piece over here, if we go all the way back to the Skittles example, if he's complaining, hey, I can't eat any Skittles, what's going on? There's 3 places here that we can find the break. He wasn't opening the bags. So we know how to test that, and we can test that I can sort them. And
Anybody else want to take a stab at that one, or?
I think that was, it was answered well. The only thing that's I think difficult to test in a distributed system is like the messaging between your little modules. Like, it's hard to to account for all the packets dropping and those kind of things. The piece that it's on one of your systems is every one of your systems needs to be able to handle those kind of faults and to recover from it. You definitely don't want those things just like crashing and burning because it missed the message or the message is bad. But
with let's say Netflix, when you create a cluster to store all the movies, how do you go ahead and separate it, or is it one large cluster where you store all the data?
I'm sorry, a cluster to store all of the movies?
All the data.
Because there's a lot of data that goes into the movies, which I didn't know until I started there. I was like, oh, sure, you just there's an MP4 file and like an MP3 and you upload them or whatever. So since I don't work on that team, I don't know exactly how they're storing those. I do know that there is a lot of processing that happens to those files. So we typically get one source file from a vendor, which is, I think, pretty much industry standard. Somebody's going to give you one asset, and then you're going to make it work on whatever it is that they require. So when we get that source file through, we might break it down because it's a different file that you'll need to watch on your desktop and on your Chromecast and on your phone. So we may go and break those down. And I know that they do have servers and clusters that are just totally in charge of that. Like, oh, new movies coming in, stand up a bunch of these and process all these movie files and then send them on down the line.
also had one more question, two more questions. How would you make the decision to either go between Puppet or Chef?
I don't use either of those, so.
Well, we use Chef. Chef is just basically a set of recipes, and it defines how well. So, for example, you might have a Postgres recipe that someone's made, or you make it yourself, and it basically just defines how you install Postgres and then what configurations. I'm not really familiar with Puppet. I'm not sure. I think those are competing products, right?
Very similar.
But like I said, we use Chef. We basically, our entire stack is recipes. So when we need like another instance of FSO for another client, we just run the recipes and it installs all the software and it's configured exactly the way we developed it. So you have, it's not like you installed it like, I don't know, a year ago and you're using Java 1.7 and 1.8's out now and this server now has 1.8 because you're just installing it on the fly and now your software's broken because you haven't accounted for that. So I guess I don't use Puppet. So
Yeah, honestly, Puppet and Chef are so similar that it comes down to personal preference. It's almost like Ruby versus Python, or well, a lot of things like that. I would tend to say, if you're really stuck, and I've been in that situation too. Analysis paralysis is a real thing, and it's maybe like one of the bad situations to be in, where you're just not being very productive. But it's I would tend to say just fire up a little server, the cheapest one you can find on DigitalOcean, install both, try them out, and just see which feels better. Because you can't really go wrong with either. Large companies use both, and small companies do too. They're able to do just about anything you need them to do. So.
Hi, my name is Brian. My question is, earlier on you stated that in a distributed system, in every system, there are definitely going to be errors. So what precautions do you take to solve the basic errors that come up more frequently?
I had to laugh earlier when Jay mentioned, it's just basic fault tolerance. Right.
There's nothing basic about it, right?
So you just type in basic fault tolerance and you're done, right? So it really depends on how those systems need to behave given any kind of errors. So, I think I mentioned that if you see like a gray image on Netflix, that means that the images that we have for whatever reason are not there. So in that case, we've decided, hey, it's okay. Like this system is fine to have a gray image. That's that works. In other cases, it may be something where you need to shut down. If you're working with credit cards or something like that, for example, if something goes wrong there, you might have to actually just stop receiving any traffic and kind of like, oh, nope, we're done, something's wrong. It may be very vital that the login system doesn't allow you to log in if your credit card system says you're not paying your bill. But then if those two stop communicating for whatever reason and you're not monitoring that, like that's kind of so there's a lot that goes into it, I guess, is like the long answer is I don't know and it's really hard.
Yeah, when you're writing tests, you have to test for failures. You have to send bad data into your APIs and see how they handle it. And it's a really good question. It's a good point to bring up because you have to think just in terms of probabilities. Every time you add another server or another system or another service, you're actually increasing the probability that one of them will fail at any given time, which is always something to keep in mind when you start distributing things out or you start having big clusters of servers. Netflix has so many servers that they probably have a failure daily, but you don't notice it because they have things like Chaos Monkey that are constantly just randomly shutting off servers, right? So, once you get to that certain point, that's what you do. You, in production, click credit card service is off. Let's see how the system reacts because you don't know until you try it in production. So you get to a certain point where you have to do that. At the early stages, it's mostly about writing good tests and remembering to do things like catch exceptions and do something meaningful with them and things like that.
Hello. So when you start designing a new project, or when you're at the beginning stages of a new project, what are your preferred methods of actually going about the design? Do you prefer to write pseudocode or work more in terms of diagrams or just code something and then refactor it into something presentable?
At Full Sail, we usually get specs from the stakeholders, so we're not really, I guess, flying blind. Generally, there's, like I said, there's 3 backend developers and there's 2 front-end developers that work on FSO, and I manage encode, so I don't have a lot of time to sit there and create a lot of detailed diagrams. So usually, we sit down in a room, we talk through what we're trying to do. There's like usually a general skeleton, and then we start trying to divvy up, responsibilities, and we just kind of tackle it. The front ends are generally pretty easy to do because you're able to prototype it, and you can actually show that to the stakeholder, and they can say, no, I don't like that, or you can change that. It's hard to do that for like the backend systems, and that's kind of where the team of developers that are working on that, we're kind of communicating, and we're peer reviewing the code that's being generated. We basically have tools. We sit in like a chat room, and every time someone makes a commit, I see the commits that are coming in, and we're looking at them, and people are doing code reviews like, oh, I saw you push this to development. Yeah, I don't know how that's going to work with the rest of the system. You really didn't listen to our talk, those kind of things. But yeah, I don't really spend too much time doing diagrams. I can't speak to other projects, but it's a very time-consuming thing. And what generally happens is stakeholders, only know so much. Like, they know their world, and once you start like actually getting into like the details that you need to actually build it, things generally change. Requirements might change. It's just the nature of the beast, and you end up spending a lot of time like keeping up with documentation instead of just, I guess, building the app. So.
When you're working with stakeholders, especially if those stakeholders aren't in the same company, you can get into some really weird communication issues. So I've generally found that actually doing UI design, at least a wireframe or something like that first, and showing that to them and saying, this is how this will work, these are the pages that you will see, this is the data that is going to be on those pages, will dictate a lot more programming and back-end design than you would expect. Every time we follow that rule with someone who's outside of the company, or across the country or anything like that, it goes much, much smoother. If it's somebody sitting right next to you, or maybe a few desks away or something like that, then it becomes a lot easier. You can figure out those requirements as you go, because you can kind of talk to them every day about all that kind of stuff. As for like my personal process for how I figure out how I'm going to implement something, I tend to write code and refactor it over and over and over and over again, just to kind of get a feel for it. But really, the right answer there is do what works for you. There's TDDs, not quite as loud as it used to be, but it's still a pretty big force in the development community, and it's so big because it works for a lot of people. Now, if it doesn't work for you, that's okay, but if it does, then do that. If writing on a whiteboard works, do that. If eating an enormous amount of goldfish works, do that. Whatever it takes.
I guess the real question was, there isn't like a documentation UI or UML class out at Full Sail, right? I didn't like shoot that down. Or is there? Do you guys teach like documentation type?
Well,
process?
they go through like wireframes. And
Oh,
like that.
well then yes, you should totally do that. That's a great thing.
How fortunate that I got to make a second question. So my second question would be, like, we discussed how technologies are ever changing. How does each of your companies and you as personally as developers handle or prepare your distributed systems to handle these changes? And how prior to the change do you actively prepare change your system?
So we just wrapped up a hack day at Netflix where it's like a 24 or 48-hour competition. And they just say, hey, go just build some really cool stuff, whatever you want, and we'll see if it works or you don't just have fun. So they really push us to be innovative like that. And I think that's kind of part of engineers in general. We're just like kind of creative like that. We like to just try to make stuff. When you're building applications and you start thinking about like production deployment and people using this, you can't always be on the bleeding edge. You kind of need to rein that back and recognize like, hey, we are going to have to maintain this. We're going to have to make updates to this. Some of the people who built it may not be here to do that anymore. So hopefully we built that in a way that we can hire new people in. If you pick a technology, like where we're at specifically on our department with Groovy on Grails, that one's being kind of deprecated and it's going to go towards the community. We're not sure if we want to continue to participate in that for this, so we're exploring new ones. So you kind of have to keep an eye on the future, but you also have to like live in what we're maintaining right now, and we have to be able to do this tomorrow. So it's tricky to navigate. When I first got out of school, I was always bleeding edge all the time, everything brand new. And now I've kind of noticed myself, like I tend to like, as React started coming out and being more and more popular, I was initially just kind of like standing back and watching. I did the same thing with Angular when it came out and Ember, and I'm actually really glad I did because I just don't like anything that Angular does at all. And then they did the 2.0 thing, and I was like, called it, But really, I didn't call it. I was just waiting and kind of watching and seeing what the community does. And I think that's always like a safe bet. If you're worried about building your production stuff right now, just wait and see. But when you get a chance, always go out there and innovate and be part of it, even if it's just for a side project, so you're aware, so that when somebody says, oh, hey, this is going to need to change in the future, what are your thoughts? You might have a little bit more relevant information to talk with.
Any other questions?
Okay, hi. So in our web program here, a lot of us, we're very hands-on learners. That's one of the reasons we chose this school. And oftentimes we find ourselves spinning up our servers like on VirtualBox using Vagrant or Composer or just local host solutions. If we wanted to actually get into building and kind of teaching ourselves distributed systems, what would be the best way to do that with the current solutions we have? Because like I can build my server and maybe spool up a couple virtual boxes, but I don't feel like that's a real practical way to teach myself getting multiple servers up and running and talking to each other.
I personally think it is. I mean, I did that a lot when I was in college. I took a lot of networking classes, and everything ran on my computer. They're still separate machines. I mean, obviously you can go out to Amazon or DigitalOcean or one of those providers and pay for that. It's just at the end of the day, you're getting kind of the same thing. There's no real difference. It might not feel as cool, but I think it's a great way to initially start it. It's like, hey, you spin up these multiple VMs on your machine. I mean, obviously, if your machine can't handle 5 or 6 servers, then that's a problem. But to spin up a couple and say like, okay, cool. I got the networking working. These servers are talking. I'm sending messages between this one and this other one. That's the way I started.
And distributed systems really boil down to typically it's always going to be going over HTTP between the two. So you don't necessarily have to build all the pieces. You could maybe start with one and maybe go out and do a little bit of research, grab some open APIs and make those the other parts of your system as you're just like, oh, hey, I want to consume this, and hopefully that their API is working and up and running. And if you're lucky, maybe you can find some that are not very stable and they'll break or whatnot. But that would get you started in at least, because really you're just saying, oh, I'm getting this information from over there and that over here, and now I'm distributed, and then I'm going to build this part that's going to aggregate those two and do something else with it. And once you get that running, there are some pretty neat tools out there. Like we mentioned Heroku earlier, DigitalOcean. I'm sure there's some for Docker that will kind of do the same as well. Just if you can get an app out there. I think Nojitsu just got bought by GoDaddy or something like that. And I don't know how theirs works, but that was a really easy way to get like one node service up and running for me. Like when I was back in school, like, oh, put one on Nojitsu, and then now I have a URL to that one, and then I'll put another one up. You can also, if you do use something like Node, and I'm sure you can do this in other languages as well, you can change the port that they're listening on. So you can spin up one on like 7001 and one on 7002 and one on 7003 in 3 different terminal windows, and that'll be totally fine.
Mm-hmm. Yeah, that's the easiest way. If you wanted to feel what it would be like to have 100 Node apps running or something like that, just spin them up on different ports. That's totally valid for distributed system, unless if you're doing something crazy with, shared process memory, which you would know if you are. So, and you would instantly regret it.
Great, thank you.
I got another question. If you had total freedom on choosing the technology stack for a project that you have to do, what would it be? For example, for me, I would choose Node.js, Express, Jade, and, well, the mean stack, Mongoose, and everything. But for each of you, what's your favorite and your go-to technology stack if you had complete freedom to choose it?
Well, I'm still a pretty big Rails fan because I can get stuff done very quickly in it, and I'm generally more interested in the product that I'm building than the tool that I'm using. So that would be my go-to, unless if, of course, Rails is just grossly inadequate or wrong for that particular project, right? If I wanted to, I don't know, collate the day's stock trades or something like that, then Rails is not the solution. It's just not that fast, right? If there's anything that I'd like to play around with more, it'd probably be messaging systems like RabbitMQ, things like that. They're always really fun, but they're also kind of have a pretty limited niche sort of application. So.
For me, and for the last couple of years, it's been Node. As far as the middle tier or server languages, I just really enjoy that. I've always used Express. I've also used Restify, and I like building apps in Restify. Building the APIs there is just, I think it's probably the best one. So if I was just going to build, I would do that, probably handle my files statically through either Nginx or a CDN. The API in Restify, and then on the front end, I'm really enjoying the Flux and React stuff that they have going on there. Like I said, I typically stayed away from UI, but I'm having fun again while I'm doing that. And I mean, they're not new concepts. So you guys are out there and people are throwing around all these buzzwords and everything. Like, it's an event bus and singletons. Like, oh, they're cool again. Like, so we're gonna do that, and we'll put .js after it and call it a framework. But it's a lot of fun to use, and it makes kind of that UI and you get to call render like as much as you want, and it's not like a problem. So, database-wise, I haven't really done a ton with that in a while, but my go-to would be Mongo, just because comfort level. Like, oh, I kind of know how Mongo works, and it's JSON, and then Node is JavaScript, and then React, and the front end, like, oh, one language, and the app's done.
I'd probably stick with the stack that we use here at Full Sail, just because I'm familiar with it, and it's been flexible for the stuff that we're trying to do, which is basically it's Postgres as our database. We use JRuby, which is a Java implementation of the Ruby language. We do that because we have to interface with Java messaging services, so we're running that to accommodate those requirements. And then I've jumped on the React bandwagon, especially after the conference they had recently, where they showed their React Native, which is, I think, an awesome tool that hopefully it takes off and allows you to kind of learn one way of doing building a UI and then be able to port that from the web and use that on your native devices as well without having to learn Objective-C or the Android platform. So.
Great. Well, thank you. You guys have some really great questions, and I want to thank the panelists as well. We're going to go ahead and wrap everything up here, and I want to thank you guys for attending the session today, and thank Peter and Stephen and Thomas for their knowledge and valuable information. So with that, we're going to go ahead and wrap everything up, and you guys have a great evening. Thank you.